we've got our little color animation thing, and it's working pretty well. You can add waypoints. You can edit the colors at given waypoints, right? You can change the ordering. That's all great. Oh, yeah. When you add them, we interpolate the color, so that's good. Now, we're going to want a couple of ways to output the data, right? One way is just as samples. You know, we'll have a little button where we say get the data as samples. But we could have another way of getting it, which is just, you know, give me the data necessary to feed in to the thing to regenerate this, right? Because like in our particle systems and stuff, we don't want to save this out as samples. We want to save it out as something that you could easily edit again, right? What are the things? And so we'll probably have a version that's like, give us the array, bro. Now, in addition to that, well, let's start putting these things out. Output as samples, right? Control the number of samples. All right. We want to be able to, well, we want to control interpolation type. Okay. Achoo! We want to control the interpolation type. This is RGB interpolation, which is almost never good. So we want to at least do like HSV. And that should probably be the default. Okay. We could have control interpolation. What should we say? I mean, this is also control interpolation type, right? Control interpolation color space and control interpolation geometry. How's that? So this is like, instead of interpolating linearly, you know, you go between the samples some other way. Okay. We've got the color picker underneath. That's already on the list to fix. Yeah, for some reason, like when the sub window is declared, we need a way to make sure that it goes to the top. I mean, that seems very easy, but anyway. So this is, we want to be able to toggle wrapping mode, right? And we want to be able to output as source data, either as a string or just really as a function is how we need it on the game, right? Now, here's the thing. We've got all this stuff for color keyframe, but like all of this is ephemeral data. And so what we might actually want to do is break this into two things that are separate arrays, or we could have a substruct here. That's what we end up returning to you. Anyway, so I think the first thing we should do is output, because, and then get desired aspect ratio for color picker and color animation editor, so that people using these kind of, because if, like the way they're laid out, they kind of want a certain aspect ratio, right? So if you need to fit them within a certain width or a certain height, then you know what the other dimension needs to be. Would it be worth to add alpha values? Yeah, that's a good point. It's really not just alpha, but fourth channel values, right? I mean, that's kind of just what alpha means. But not really necessarily about opacity. This is more like if you're doing HDR or something, you just might want it to be very bright, for example. It's another use of a fourth channel. Then, this is turning out to be a lot of things. We want a time view. So this is like a space view, right? So I want to at least be able to pop open a thing that just like shows the color over time in a way that you could see. Okay. Now, let's start with the output value, because if you can't output the data, it's not very good. So we're going to make, I'm feeling like 3 columns below here or something for different kinds of controls. So let's just make some areas. So draw color adjustment is doing its own. Yeah, I think that's fine. So we get this area, that's the area of the whole thing. Oh, you know what? There's some more things. Restrict, what do you call it? Restrict highlighting to when the mouse is near the active rectangle. This is the thing about how you could be anywhere within the big area there, right? Okay, so this is for the color slider. But we actually we're going to say controls area is going to be a rect. Is where all the buttons, inputs, etc. will go. Controls area is going to be area. Controls area dot dot what? We just want to say, I could have done this by chopping, but instead I'm just going to say whatever dot h equals bar dot y minus some margin minus area to y, controls area. Okay, here we have this. Okay, now we're going to go cut left, controls left, controls MR is going to be cut left, split the controls area into 3 columns, cut left, controls area by 0.33, sure. Actually, is that, what is our, oh, that's literally pixels, which is fine. And then controls middle, controls right, are going to be cut left of controls middle and right by 0.5 times controls mr.w. So we're just getting like 3 regions roughly. Now, in the rightmost region, we're going to want, I mean, we need more themes and stuff, right? So we're going to want we're just going to plan ahead and have a text input, and it's not going to get used yet, but we're going to have a text input, and we're going to have a button. All right. And these are going to be you know, the ways that we generate the output. So let's go to the button first. So we need output button rect copy to clipboard output button theme, and that's it. So we want that to be a pointer to our own thing, and we need the rect. So we need to know how big we want the button to be, right? And we kind of want, let's just make the theme. So on our theme, we're going to have the theme just for various buttons. We might want to make this sub-themable later, like maybe the buttons in different columns or down to the individual button. But for now, okay. For some reason, we started having our code creep in between our data declarations here. All right. This is just called button theme for now. So we get that off there. Now, how do we decide how big our rects are for the button? Here we just told it. Yeah, I guess we can go, we probably want some function later that's like, what is the button rect for, actually, the way that we're doing get aspect ratio, we kind of want something like that. Anyway, so I don't remember what's the good way to do this, guys. This is how long it's been. So yeah, here, button height. How are we picking button height here? Yeah, we're just, okay, we'll just do this for now. Incomplete, it would be nice to have a way to more automatically size buttons. That might not honestly be a thing that really makes sense, but we're just going to go button height is bar height times 0.2. That's probably, we're just going to see how this is. And then output button rect is going to be cut top of controls right button height. Okay, so back when we did this, this is bar underscore y state.button theme. I did it again. Oops, I did it again. All right, copy to clipboard. Boom. Now in reality, we're going to want some margining between these, some margarine between these regions, but this is fine for now. So, yeah, if you want to enter the numbers, you just do that off the color picker. Okay, so now we're going to go this is a thing that gets a little bit messy about this, but here we go. Now before this, I want to go samples. So samples input rect remainder 0 is going to be cut top controls right button height. All right, and then Boom. So, I don't know about that. Now, text input. We need the rect, right? Text input, samples input rect. Inert text is going to be, I don't know. We actually don't care right now. Let's have that be empty. Theme, samples input theme, we're going to have to add that. And, oh, we want a label. I never know how much to allocate for the label. Okay, so first we want a label, by the way. Label rect, number of samples, label theme. Yeah, we're just not going to get too specific because we'll have a bazillion themes flying around. We're just going to do this for now. And okay. Okay, so we got to add the themes, and then we'll get more jiggy with them. Button theme, label theme is a label theme, and input theme okay. Oh, we didn't make enough space. You know, this is just for an integer, so it doesn't have to be that much. Number of samples, 0.6. Okay, that's we want to do some stuff. I mean, we want to have some padding. Between this and the buttons. VPad is button height times 0.2. All right. And pad is a rect. So here we're just going to go pad, comma, controls right equals cut top. Let's do this. Okay, so now we need some stuff on this theme. Wait, where's label theme? Did we put label theme somewhere? It's in themes. Label theme, alignment. I guess write justification. I don't actually know. This is, you know, we're going to want to move all this stuff around later anyway. Okay. These themes are all, we're going to have to make the defaults better, but okay. Now, we will want to, well, okay, like I said, we're not going to pay attention to the number of samples yet. First, we want to get this working, the copy to clipboard. See how it's still highlighting when I'm on the right X position. This copy to clipboard, we want that to work. So, first we make it copy anything. All right. If pressed, copy samples to clipboard. All right. Cool. Copy samples to clipboard. Well, we want to go here. How do we do this? We're just going to go here. Why is this putting hello sailor directly? This is a fucking lie. Who wrote this test program? All right. So this is not a good name for this. Okay, we're just off editing other stuff. It's fine. What is going on, dude? What? Okay. This must be some old ass shit. Okay. So, yeah, we're going to import that. We're going to go, I don't know why we call it OS clipboard set text though. We should clean up that name. I mean, that's it so far. Color animation editor state. Okay, doesn't matter what's in here because boom. Let's make a new file. Boom, there we go. Now we could generate the samples. Okay, so we already have a function that generates samples. Okay, we don't want to be in clipboard land anymore. So remember we did this stuff. The way we draw this here, and I mentioned quite a long time ago that we would possibly Um, you know what I'm saying. Refactor this. So let's just refactor this, but keep it in the same function. However, well, okay. So color samples is this a local? Where'd that come from? Okay. This should be on the state probably. Temporary color samples used for rendering. The actual long-term color data. All right, so we're going to say generate color samples state to we're just going to do this for now. There's no reason to make it more complicated than it needs to be. And if we want to specify color space later, we could do this. Oh. Let's do that. Because we don't want to require it to be a statically sized. Yeah, we're just going to do it. We don't necessarily need to do this for calling the function, but to have a short name for it when we come back and render, it doesn't matter at all. It doesn't matter. Okay. So here, oh, whoops, I forgot that we were leaving this. I started deleting the block, and it's like, no, because we want to change color spaces and stuff. Oh, but that's not actually where we would do it. We would do it in generate color samples. All right, anyway. Generate color samples gets a state and probably some arguments later, but here we go. State and samples is in vector 3. If there's no count, we return. Okay, get sorted keyframes. We assert sorted.count. Fine, we're making this more general use. Okay, hold on. If Okay, so this way we don't have to worry about dividing by 0 here. Okay. Oops. Right. All right. Okay, so it still works. We still have our situation. We can still edit the colors. They're great. And now we actually can call the function from elsewhere. So when we're going to output, we're going to say the following. Copy samples to clipboard. We're going to go, a builder is a string builder. Actually, yeah, it's fine. Num samples is going to be 5. Let's make it a number that we can tell what it is when we paste it. All right, so we're going to go for we're going to generate samples.allocator is temp, array resize samples to num samples. All right, so now we're going to generate those samples. We're going to have a string builder. We're going to go for we're going to say print to builder right, and then text is going to be to string, builder to string. I always forget that. Okay. So it we'll just put a comma after literally everybody. Okay, copy clipboard. Boom! There's some colors for you. Easy clap. Although actually, because we're doing this, because we want to let you paste this into code, I'm going to put the dot beforehand for now. Let's actually do this. Append and if you don't want those, you could just chop them off for now. All right. So copied clipboard, bam. There's your vector. Okay, so now we actually want to be able to tell it how many to use. State.num output num clipboard samples. All right. How many samples we output when you copy to clipboard. Okay. Cool. Well, now we want to let you do that. Let's look at our text input theme. Because I think we have some flags on here. We have some stuff about, oh, it's just a number or whatever. Number entry, oh shit. Number input. Forgot. Okay, let's do that. Okay, so instead of text input, I'm going to go number input. And then the inert string is going to be tprint of whatever with num clipboard samples. All right, inert string. Oh wait, maybe we don't do that for number input. Hold on. Oh, we do. Okay, so value. So we're going to have pressed or whatever, changed is going to be number input of this stuff. And we're going to have new value is we're going to have at least one sample, and at most, how many samples? OX, FFF, I don't know, that many? That's a lot of samples, right? Number input theme. Okay. If changed, state.num, you know, now I made this separate because I was thinking we need to clamp it and all that, but I think this already does all that, so we don't, I think we can simplify this a little bit, but we'll do this. Your declaration have changed. Oh, yes. Number changed. Okay, number of samples. It said 0 for some reason. 33. 250, 215. Copy to clipboard. Okay, is this going to be 215? Sure looks like it. All right, you guys ready? You guys ready? 1 million. Oh, that took a little bit longer. Emacs is choking. So we were able to generate 1 million things and put it in the clipboard, but now I try to paste it into Emacs and it fucking takes however many seconds that was. Dude, I can't even go to the previous line. What is this dog shit text editor that I'm trying to use right now? All right, we knew this would end in tears. I just hit Control P to go up a line, guys. That is literally what I just did. Now, you'll note that we have 1 million vectors where each one is, you know, I don't know, 16 characters. So it's at most has to search backward through 16 megabytes of characters to find the previous line. If it's a horrible slow system, how fast do you think you could scan through 16 megabytes of characters to find a new line? Pretty fast. What is this doing? I might have to kill it. CPU. GNU Emacs. It says 6%, but that's an entire core, is what that means. Can you hear the fans? See, if I kill my Emacs, I have to... okay. Kill it! Thank you. All right, at least we know that we're actually outputting a lot of things. They don't expect large memory outlets. It's a 16 megabyte file, guys. This computer, that's like, you know, 1/4000th of the RAM on this computer or something like that. If your text editor cannot deal with a file 1/4000th the size of the RAM on your computer, it has fundamental issues. Fundamental issues. Okay. So, now, why does it start at 0? Oh, because I didn't set it to anything. I don't know, 16? Like, what do you want? What do you want from me? Copy to clipboard, 16. Boom. Okay, I think we take the W and make some T. Oh, let's do this. We can just do this here. right? So if we go 0 is clamps to 1, minus whatever, minus something we didn't understand. Okay, what if it's way too big? Then we get that. Okay, great. We're not copying that to the clip, or we could copy that just fine. It just, that would, if 1 million took Emacs that long, and it's a nonlinear slowdown, how long do you think 16 million is going to take? All right, I'm going to take the W. More color, animation, editor stuff. It's time for me to make some more tea. Given the frustrations Emacs seems to cause, why do you stick with it? Because every fucking editor is complete dog shit. Like, why are you even asking this question? What do you think would happen if I tried to paste that into Visual Studio Code? Do you really want to know? Do you really want to try that? Can we try that just for some? No, I'm not going to install it on this machine. Dude, what would happen if we pasted that line into Windows Terminal? Dude, Visual Studio Code, you can't even type in real time. Like, I type faster than Visual Studio Code puts characters on the screen. Like, it's just not going to be able to handle anything that a JavaScript beginning programmer wouldn't type. So, like, at least in Emacs, I usually can't see latency between when I type and the character comes out. All right, any technical questions on what we just did before we move on to the next part? We have done both of these. Questions? While I put the tea on. Notice if not, why do you think theme is an integer? Theme is not an integer. When is the next beta Q&A? We're a little bit overdue for it. I suspect maybe the end of the coming week, like Friday, something like that, Thursday. I just want to give people some time after I announce it to know when it's coming. Can I show the program running? We've been showing the program running this whole time. What do you want from me? Okay, so what are we going to do next? Oh, that part, that'll be pretty easy. Oh, interpolations. Hell yeah. Hell yeah, my mans. Les mans. How does GetRect handle things like overlapping mouse clicks with two elements that you can click on the same pixel? It depends. Okay. There's sort of a concept of... So hold on, my tea is boiling. We'll get into this for a second after I get the water. Okay, we'll start by saying, occlusion here in general is definitely a little bit in flux. Like, we're figuring out what makes sense to do over time. But the way it works right now, because I wanted to keep overhead down, it doesn't work like your typical object-oriented widget set thing, right? In one of those, like every single thing that you ever draw makes like an occlusion over what's behind it and stuff. And I just didn't want that. Like, normally if you're drawing something in your own program, you're drawing it laid out in 2D, so you don't really want or need things to block each other. The time when things block each other is either, pop-up windows like this or, like a drop-down or whatever. But you want that to be a pop-up window because, like, what if this is here? You want that to come over it, right? So the way it works is, like, there's pop-ups that declare occlusion rectangles, and those persist from frame to frame. And on the next frame, you just sort of ask if your widget can see that the current mouse position, basically. Now, this is a little bit broken somehow because we noticed, actually it's not, oh, there we go. So we're not like currently, it's weird, it's kind of working. So notice, so here's my golden monkey text input, right? It goes active when the mouse is over it anywhere. This might just be a bug in the button code, but so when this window's over it, it recognizes that it's not active, and when the mouse is over here, right? The bug is if I click over here, it's not correctly realizing, right? So we need to look at that. But you can tell the basic occlusion system works because it's not highlighting here until you're actually there. But yeah, it's a pretty straightforward thing. Now, in addition to, like the way, I'll show you in practical terms, because you want to make this as easy to do during programming as possible. So what we do is we say get status flags for some rect, right? It's get rect, so everything is about rects. So you have some rect, like say, let's say for a button, right? If you were implementing button, you would say get status flags, right? Here we're implementing, you know, this thing, right? Except I think we passed the wrong rect in there. But anyway, that's on our bug list. Maybe we should do that next. But we get the status flags for that, and status flags tells you, you know, what's happening with the mouse buttons and all, because that's usually what you want to know, right? And so, you know, this means somebody pressed the mouse button. Now, all these will just be automatically masked off if it's occluded, right? So you don't, you know, you don't have to register with an event queue or whatever. You just say what's happening in my rect, and if it's blocked, it's blocked, right? So this is a way of decoupling code from other code, which is a good thing to do, right? Like in a lot of these widget systems, there's these fucking just gnarly event handler methods that call each other like forever anytime anything happens, right? And this just gets rid of all that. Okay. Do you ever use state charts or other techniques to understand the possible states? I'm sorry, that's an extremely beginner question. Do you have any idea what the state chart for the witness would look like? This is just not, like at any level that makes sense, it doesn't make sense, no. Like, you know, when I first started to learn programming, I, for example, because flowcharts were big in the 1970s and early 80s, when I started programming, I would flowchart out my programs, but you very quickly get to the point where, like, your skill is past the usefulness threshold of a flowchart, right? Like anything, any program that a flowchart is going to help you with is just, the flowchart itself would be so gnarly, right? And the state chart is a different thing, but it's similar. I look like LLVM documentation. Yeah. At some point, flowcharts become useless and slow you down. Yes, and that point, what I'm saying is that point is so early that they're just not useful once you're an even mildly experienced programmer. How long have I been programming for? 41 years. I turn 20 next week. Asking if there were techniques I'd suggest. I mean, just practice programming, right? You know, what you learn to do as a programmer is you have some map of the program in your head, and it's some abstract structural map, and you're just looking at that and just being like, okay, I'm seeing a certain bug. What behaviors would be the cause of this? And you learn to like look at the program model in your head and use that to, well, both to determine what to program and to figure out what's causing bugs and all that stuff. So the sooner you get good at that, the better. Do you find it useful to look at other programs already written? I mean, I think that's tremendously useful when you don't have that much experience. The more experience you have, the less useful that is, unless there's something very domain specific going on, like, oh, I'm looking at signal processing code that I'm not familiar with that domain, or maybe it's a different paradigm of stuff, like, oh, this is an immediate mode GUI. I've never seen one of those. Let me see how that works. In those cases, it's worth looking at other code, but the vast majority of code is not worth looking at, right? That's the sad truth. So it really has to be contextual, why you are looking and what you expect to get out of it. Or, you know, another case, if you're learning a new programming language, it's very useful to look at example code in that language. Or if you're learning like a new API, I would much rather see example code than documentation. Yeah. What computer science course was most impactful for me? I mean, none really. They just, I don't know. Like the actual programming experience that I have dwarfs any academic experience by like multiple orders of magnitude at this point. You know? It's just not, what I learned in college is just not even on the map anymore. It was maybe useful at the time to help level me up slightly into a more serious programmer, but it was a very inefficient way of doing that cost me greatly. And if I could run life over again, I wouldn't go to college for sure. The problem with all these courses is I mean, it's a sad fact, but a lot of them are mostly filler. It's like they kind of have to fill up 4 years of college in order to make it seem like it's worth the money, right? So you go to a data structures class. Now, the foundations are very important. You need to know what a tree is. You need to know how to write recursive things that navigate trees and whatever. But you probably saw that before the data structures class. So the actual data structures class will go into like 17,000 different flavors of trees that nobody cares jack shit about, right? And it's like, okay. I mean, you probably should, like, for example, you probably should spend a week or however long it takes balancing a red-black tree or something like that. But after a few basic things, you just get it. Like, it's the important thing is the core ideas of data structures, right? What about for the experience? No, you get way more experience programming on your own than you do doing homework. Like if you actually sit down and program, right? A lot of people don't. You mean the social experience? My social experience in college was living in the computer lab and girls not paying any attention to me because I was a fucking nerd. Like, okay. Like, what social experience are we talking about? Okay, let's get back to programming. I didn't meet anyone cool. I mean, I think different people are different socially. I stayed in touch with some friends from college for a while after that. I mean, I started my first company with someone who I met in college, but, you know, after that company was shut down by us, I didn't really much keep in touch with him. Yeah, I don't know. I mean, none of the people I knew in college. Yeah, I mean, just over time, all that stuff fades out in favor of other relationships that you make, right? I think that's how it worked for me. I don't know. Maybe for some people, you know, are still going to Tahoe in the summer with their college buddies or something 30 years later, but that seems weird to me. Okay. College is obsessed with ChatGPT. I mean, it's the current thing, right? It is $ current thing. Yeah, the thing is now, with the internet, you have the ability to make social relationships, you have the ability to learn about computers, right? You can go watch Casey videos, you can go watch Uncle Bob clean code videos, you can go read tweets by people who want to cancel Uncle Bob because maybe he hit on a woman once. I don't know what that was all about. You know, you can see all these things. And so, why did they try to cancel Uncle Bob? Somebody summarize it for me. I'm not talking about the Casey thing. I'm talking about like in 2019 or whenever, when people were trying to get him banned from talking at a conference. College is not only about hard skills, but also about soft skills. I mean, tell yourself whatever you want. I didn't really learn any social skills in college. Or whatever you mean by soft skills. Drama around the Factorio developers. I never heard of that. Okay, let's get back to it. Right. So like I said, I think I'm passing the wrong rect into here. Yeah. Actually, maybe not. No, this should be restricted. Let's remind ourselves about get status flags. So we look at the mouse for the current frame. Oh, we check the scissors. We check occlusion. And we check we're inside the rects. Am I not checking this correctly? Oh, I'm not checking this correctly, right? Because here, see, we're just setting these without regard to, yeah, okay. So here we're just going to say picking mask, right? And that is going to be, we'll set it down here. Picking mask, status, and right. I don't have the status. Oof. Okay, we're going to move this out. All right. So now we still, this is working. We're not masking off the Y yet. That's like a separate thing, I think. But when we open this, we're still, fuck. What? Oh, wait. Wait, what? Picking mask. Let's call it activity mask, by the way. This is not even right. It's this one. Actually, we don't even want that. Dude, we want to not set it active. There we go. Did I delete that line completely? I might have just done it. Yeah. Okay. There we go. Boom. Hey, you have to be in the rectangle. Check it out. Check it out. And if we do this and we move it over one, this one stays up because it's color picked, but here we're not activating anymore. Yay. Okay, great. 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 Okay, did we check in before? I think we did. Anyway, we're going to put this later because it's less important. Because for the game, we just needed the API to this, which we'll probably make. Anyway, let's do fun. Okay, so on the left, control region. There we go. Here we go. Here I want to say shrinkage is bar height times 0.04. Margin around controls areas. All right, and we're going to go controls left is shrink. Is that actually the right one? Shrink, yeah. Controls left, middle, and right. Because we want to be able to stack up buttons in each of these without them running into each other. Oops, left, middle, and right. Okay. Now, on the left, we want to do a drop down. Okay. Let's do this. This is controls right, copying to clipboard. And here we're going to say controls left is interpolation parameters. Okay. We're going to want to do some drop down. And the way we do this is, right, we're going to have two of them. We're going to want to put a theme as always. All right. There we go. We're going to do drop down. Now, we're going to have wait, what did I just do? Oh, that's the handle. Wait, what? Oh, right. Okay. Yeah. Okay, so the first one, this is going to be color space names, state dot interpolation color space. The way the drop downs are, because I didn't want them to be polymorphic, the argument is always S32 right now, and we could do that later. Interpolation geometry names, I don't know. State interpolation geometry S32. Okay. Now we need, what are these rects and stuff? Right, so the button height we already did. And then VPad we already did. Okay, so we have those. So we're going to go I'm just going to try and make this less verbose. If I'm going to use the same remainder variable, we don't need to call it remainder 0 every time. And okay. All right, so color space names is RGB and HSV. All right. And then interpolation geometry names linear, quadratic, and hermite. All right, and then we need these variables. Edited by the dropdown and interpolation geometry. That's 32. What? I did it again, dude. I did it again. Controls. Okay, so these currently do not do anything, but here we go. Easy clap. I mean, really, we should put these next to each other on the same line, right? So let's do that. Color space rect and geometry rect. All right. Like that, we probably want to put some pad between them, but, you know, yeah. What? All right. Cool. So, cool. It's been a little bit since we took a W, so let's check this in, and then we'll make these work. Okay, now add a third parameter that would be a pad. Yeah, I mean, I'm thinking about it. Definitely you could think about cases when you want that. I'm always try to be slow to add more functions, right? Just to prevent code from bloating. But I was definitely thinking that. I was like, you know what? If we had cut functions that took a path, in fact, they might actually already, it being honest. No, they don't. But you could imagine that, because I think usually you want margins between stuff, right? Did I ever regret not naming? You saw me be lazy in one commit message one fucking time. Have you ever watched this stream? Do you ever see my commit messages? And you're asking this question. No, I did not ever regret not naming commits better. Jesus. Go build something in the world. Like, get off my dick, as the kids used to say. All right. Now, sometimes you got to let off some steam. It's really warm in this apartment again. You tend to write 3 paragraphs. Well, I mean, that works too. The thing is, the time you spend writing commit messages is time that you're not programming. It just depends how often do you commit. I mean, this is a little bit slow because I'm doing just streams, but sometimes I commit 30 to 50 times a day, right? So like, am I going to write 30 to 50 paragraphs? Probably not. Okay. Yes, so now we have color space. So when we generate samples is when we would do that. Let's actually make a parameter to this called interpolation. Because all right, so we're going to go all right, and then okay, and then we're going to have wrapping. Okay. Now, get interpolation. Actually, let's just do this. Result is an interpolation. Result.color space is XX, state dot whatever, right? Geometry. Return result. And then here, like that. And that's fine. Still compiles. We're not using any of this right now. Right now. So, let's do the color space one, right? So, okay, now when we do this, we say the native color is always stored in RGB, but we will compute a target space, key.target space for all keys if interp is not equal to RGB. Actually, for sorted it dot actually is it color keyframes? Yes. For state.color keyframes, it.target space equals it.color RGB. All right. Otherwise, if actually invalid color space in generate color samples, comma, interp, oh. Okay, if it's RGB equals RGB to HSV, okay. We didn't make target space. Okay. Cool. Now down here, instead of color RGB, we want to say target space. Okay. Okay, we have an RGB to HSV, but it is different, so okay. Wow, that's brighter. Something seems wrong about that. Oh, because we're fucking... Yeah, we're returning HSV values and drawing them as RGB. That's not very smart. Right, we want this to affect the interpolation, not the output color. What am I doing, guys? Okay, so... So this is all fine still. But this part, the target space, we're going to change this back. Okay. Here, and then we're going to go if if we want to do the same thing, we want to do the inverse. If space, the terrible secret of space. But instead of this, you just say RGB equals RGB is target, or RGB is HSV to RGB target. All right. So we got to do this as well. HSV to RGB, HSV, GB, HSV to RGB. Fuck. Okay, and then RGB. Cool. Target's been canceled due to having a pedophile kids section. So, okay, this looks really wrong as well. The actual, it's very weird what's going on here. Obviously, I've messed this up. Don't I need through? Oh, yes I do. Ha ha. That was exactly the problem. Lol. Okay, RGB HSV. Wow, that's not good. Okay, so here's what's going on. In HSV, right, your hue is a circle. And if you interpolate the long way around, it's kind of like quaternion slurping. Like violet is next to red, but we want the long way around between violet and red, right? So, yeah, probably I think we do this. We go RGB is lerp, right? Or we're going to lerp these individually. Because the H is going to change. Okay. We have to go the shortest way around. And we need to know what the range is. So we're just going to say, just going to log a bunch of fucking H's. Oh, lol, S is our parameter. Ay, ay, ay. Okay, boom. So it looks like we're 0 to 360. Okay. H goes from 0 to 360. We want to go the shortest way around. We're going to go dude, I fucking hate fighting with Emacs about indentation all the time. H0 is that. H1 is that. If H1 minus H0 is greater than 180, right? And then if H1 minus H0 is less than minus 180, H1 plus equals 360, right? Hey, how's that? It's not muddy. It's not muddy. It still could be better, but it's not muddy. See, violet is a long way from green in terms of hue here, right? Like it's barely, it's about as far away as you can get, which is why this goes through so many colors here. Deserves an ice cream. We are low on ice cream. I think during the next break, I'm going to be going to the store and getting drinks and ice cream. Okay, so this is fine. We could put CIE lab in here later if we want. It's also, you know, to be honest, there's a question of should you interpolate in gamma 1 or gamma 2.2? This is in 2.2. I think. You know, so you're not seeing a lot of yellow here, for example, because you're seeing, well, okay. Let's actually put these at the endpoints. Yeah, yellow kind of gets lost. You know, color spaces are like this. Okay, let's try putting some blue. Oh man. Okay, so here, you know, we're kind of getting a lot of aliasing in the colors because the interpolation, the gradients here are just really extreme, right? So it starts kind of looking a little crappy. I feel like, so right now we're just doing 500 samples, and this is like a 4K. Let's just do this. Not that num samples. You know what? Fuck it. Num samples is cast S32 rect.w, right? 1 per pixel, bro. All right. Num samples equals if x else 2. I don't know, 1. Do we divide? Yeah, let's do 2. Okay, so that's how many samples equals temp. Array resize samples num samples. All right. So we do that. We're just burning temp storage, which, actually, maybe that's bad style. Maybe we should put that array on. Anyway, so if I put something extreme here, that looks better. I mean, I don't know how this is looking on Twitch, right? But like, the space is, the results are kind of sharp gradient wise here, you know. So, and you start to see weird effect, like mock banding looks really strong here, which is, you know, a psychological effect. Now, if you're in RGB, you don't see that mostly, but it's just a bunch of mud. So it is what it is. Let's try desaturating by a lot. Oh, that's kind of a singularity when you go to 0. That's it's like when there's absolutely no hue. Yeah, we're going to have to look at that little numerical instability. It's like if it thinks there's some hue, then you go around the hue circle, but here it's like we're not traveling in hue space very much or not at all. And when you're very close to white, it's like, do you have hue or not? Right? We don't know. Anyway, we can go to HSV here, right, and control this. See, if I'm right on the edge, we stop traveling in hue space. So that's, we could think about what that means. Mock banding should improve a lot by interpolating in linear, yeah. Yeah, we could do that. We could add a checkbox for... See, this is weird because this is linear, but it's different linear that we're talking about, right? So maybe we'll just have like a gamma correct checkbox or something. The thing is, depending on the application, you don't care about mock banding, right? If you're talking about colors that a particle is going to go through, don't care about mock banding. Add dithering. Yeah, we're not going to add dithering to this. That's not needed. You could imagine it though. I mean, maybe, well, here's, another project we might do is the simp auto shader translator, right? If I could just write a little function that dithers hue in the rectangle a little bit, I might do that. But I can't do that because who knows what the graphics API is. It has to be a completely different programming language, right? But if we give you a way to do that, then that's pretty good. All right, I didn't think we would get this far today. So this is great. Okay, so this is hooked up for now. That's fine. This part we do next. Let's take the W again. Actually, let's do wrapping first as well, because that's easy and we can get it off the list. Added color space interpolation, or color space choice. Okay, now wrapping. Should be easy. First, let's make the checkbox. So we're going to need a checkbox theme. All right, and then we're going to want okay. We're going to call checkbox, and let's see. We're going to get our checkbox theme. Base checkbox. Why am I calling base checkbox? Because I never cleaned that up. Oh, because radio button is different, I see. We're disambiguating that radio button also calls this. Box R for the box. Oh wait, checkbox has? This is a little bit, yeah, I don't know. We'll see. See how we feel about this. R, this checkbox is going to be wrapping and state.interpolation wrapping and checkbox theme. All right. We need to add, oops. We want to add this variable to and then get interpolation. No cast needed there. Dude, I literally do this every single time. Every single time. Every single time. Okay. Oops. Let's just check the return value of that. Okay. Wrapping. Boom. Boom. Easy clap. Okay. Colors are ugly. It's fine. We'll deal with it later. Well, now we have to actually wrap or not. Okay, so if yeah, let's just let's do the following thing. I0 is color cursor. I1, okay, and then if interp.wrapping, all right. So we're just going to wrap ourselves around the little thinger. Okay. Else so this way we don't actually need all this logic. Okay. We just have this case. This is I0 and I1, But now we just control what are I0 and I1. All right. Dope. Array bounds check fail. 620. Sorted I1. So we wouldn't be wrapping at startup. Oh, it's not samples.count. Samples is the output. Sorted is the input. It's just, you know, sometimes even just having two variables that start with S, it's kind of confusing. Okay, so here you see we're still clamping to the endpoint with the solid color, but we're doing it a different way. Instead of having special code to do that, we're just setting both the indices to the same index, and then we're just running our same interpolation. Now, if we're wrapping, it doesn't fucking work. Ta-da! Like, it's definitely changing. Oh! Yeah, because the t values, see. There's probably a more economical way to do this. We're just not worrying about it. All right. Wrapping. Oh, God. Okay, well, it did something. It did something. Oh. Hold on. This is what happens when I just write code without really thinking very much, which I do quite often. We also need to wrap T. That might not be the only remaining problem. Hey, check it out. So we'll change this over here to like blue. Boop. It's almost like we could program line 655, adjust padding. 655. What? 625. What? The if above. This one? Oh, are you talking about this? Okay. Okay. RGB, HSV. Wrapping or not. Okay. See, in this case, RGB versus HSB isn't a ginormous difference, but it's more colorful this way. Okay. So we're going to take that W, and then we're going to do our interpolation. I don't know how to do quadratic interpolation or whatever the fuck. So we're going to look that up. But first, I'm going to take the W. Handle wrapping. Okay. Quadratic interpolation. Second order polynomial making unlike linear interpolation. These just... I don't... Doing arithmetic with Python, no. Okay, quadratic interpolation. B1 is f of x1 minus f of x0. That's the slope. Do I want to watch all this guy's slides? Oh, this is the slope and the curvature.
We have this quadratic polynomial or quadratic interpolation. Okay, so
And then this is the curvature term. Oh, right. Okay, this is between 3 samples at a time. I forgot that part. Of course, you need that to do higher order. I kind of don't want to do that right now. We can add that if we want. The mic. What do you mean, the mic? I don't know what your problem is. Okay, so sound was echoing. Yeah, but I wasn't listening to it either, guys. I was just looking at the slides. Okay. So the Eremite interpolation is you make a cubic spline, you set the slope at the beginning and the end to 0. And this is nice because, again, it's isolated between 2 sample points. The thing, I think if you do the quadratic, it doesn't. I don't know. We want things that exactly interpolate, right? Or exactly meet the endpoints. Let me see if I already have a... Nope. I certainly have it in previous games. What? Okay, this is like higher order stuff. Do I have to get out a notepad and figure this out again? Wikipedia is so bad for math. This is not even what I'm thinking about. Like, I don't understand how you can be as bad at explaining math as Wikipedia. It's quite astonishing. Also, computers. All right. Yeah, we just want the special case. We just want the special case where the slopes are 0, right? At both points. So I think we can just use this. Let's just do it and see what happens. Okay, so this is kind of this annoying n squared thing that we're going to get. Let's just do this. Easy clap. Hermites for termites. Okay, so we need both the scalar and the vector of this. Result is 2 times t times t times t minus 3 times t plus 1 times a plus minus 2 times t times t plus 3 times t times b. And then for vector 3, we're just going to pasta this. No, not t is not a vector 3 here. Okay, HSV. It doesn't look a lot different. It does look better though. Here, let's get full screen. All right, so here's linear. Boom. That looks better. That Bennett would like that better. Let's put a steeper gradient in here. Oh yeah, that looks so much better, guys. See this mock banding in here and stuff? Gross. Better. Maybe we'll just make this be the default. Because it just looks better. You know what's very interesting? Vertically, this is just the same color. There's no color difference vertically, but these look like strangely shapen smears to me. My eyes do not see it as straight up and down. Okay, but yeah, so that's less muddy. This is also... Check out the link for quad. Oh, that's right. I forgot. Okay. Yeah. I forgot there's this cool website. No, this site is dope. Yeah. 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 Wait. This is just a mapping of the parameter from 0 to 1? Is that the way this works? Yeah. So we're just remapping T in this case. All right, so let's put this here and we'll say from easings.net, ease in out quad, T is a float, to a float, and return, like, I don't want to read this spam here. Return 2 times x times x. I mean, I get wanting to do it branch free by default, but for now, we're just trying to understand. Return 1 minus math.pow. Wait, they're calling pow? Bro, you failed computer school. Holy crap. Oh yeah, x to t. Like, how do you call pow for squaring something? Jesus! It's probably actually faster in JavaScript for some reason. Okay, so let's put that in. Should we call it quadratic or quadratic, or I don't know. Okay. Linear quadratic, air meat. Quadratic and air meat look exactly, they look so close to the same. I can see it change a little bit. But like, it's hard to notice. I do see it. Let's put again a much steeper gradient in here. Let's make it go to cyan to cyan to yellow. Actually, I wanted this one to be yellow. To violet. Okay, RGB, linear. See, the yellow kind of is getting buried again. Quadratic, pretty good. Air meat, yeah, they're. Oops, I accidentally clicked wrapping because because it goes all the way out to there invisibly. All right, because we made the box this big, which is, yeah, okay. Can you guys see it change here? Between quadratic and air meat, they're close. They're close. I don't know that anyone's ever going to really care for practical purposes. Do I care which one? I don't think the default should be linear. You know? Let's look in HSV, because we're probably going to default the space to HSV. Actually, we should make the space lab, right? We should add lab. Linear, quadratic, air meat. Much bigger difference here. I think the air meat is better, but not by a lot. Like, the difference is not huge. Like over here, the cyan is getting more buried in quadratic. Do I use a calibrated monitor? No, this is literally, an Asus laptop display, so you should not take too seriously what I'm doing right now. Anyway, this is all fine. Like, whatever the defaults are, we could change later. Okay, so I kind of want to take the W on this, and then maybe we'll do lab color space, because like HSV is nicer than RGB, but I don't quite feel like it's a good default, because this is just like going around the fucking hue circle all the time. Sometimes you want that, right? If you're making Nyan Cat videos, you want that, but it's not always the right thing. This is also not always the right thing. Nyan rhymes with cyan. Poor yellow. I know, dude, yellow gets disrespected so hard. In lab, yellow would be bigger, which is probably the reason to default to lab. Yellow gets no respect. Okay. Yeah, we'll take the W. We're getting so much done today. Guys, we're already as far as I would have hoped to get by the end of the weekend project. Right? Like little bugs like this and whatever, fourth channel values, whatever. Time view we probably want to do. Yeah. All right. No, we're doing great. This weekend project has been butt kicking. Now, depth sorting on color picker. Interpolating in linear. Yeah, oh, yeah. Gamma correction. All right, so let's just, let's actually, let's make a version of cut left. Okay. We're going to put the margin in here. As an ease of use experiment, added a margin to cut left so you can more easily make widget rects with margins between. If successful, will propagate this to the other cut star. Okay, so I'm going to call it M. Remainder dot width is rect. Wait, it's amount minus M. Oh, I'm so confused, dude. Okay, this is plus. Okay. Let's try that. So back over here in color animation editor, when we do the controls area, we're going to do this with shrinkage. Okay. Boom. Okay, so the reason I wanted to do that is because I wanted to do it again here where we go R wrapping and R not wrapping. Gamma is going to be cut left R 0.5 times R dot W shrinkage, all right? Wrapping changed. And then gamma changed. Gamma. Well. Okay. Okay. If true, we interpret the colors as being in gamma 2.2, convert them to linear, interpolate, then convert back. Back Holio. Yeah, gamma. This is our wrapping and our gamma. Boom. Okay, we got, that doesn't do anything. Oh, because I also, yeah. Yeah, state interpolation. Wait. Oh, if gamma changed. Lol. I should just pass a pointer to the Boolean in here. It's probably what would make ease of use better. Gamma wrapping. Okay. So gamma does nothing right now, and it's not going to do anything for a little bit. I just wanted to put it in there. It's there in the widgets because this margin thing was bothering me, so I wanted to get it going. All right, now. You know, it's actually pretty easy. Let's see. Let's try to do gamma. The question is, so for some color spaces, it's like, does it matter? So, you know, you could gamma down the RGB and then convert, which I think is the right thing to do always. But like maybe the conversion matrices are different. You know what I mean? In theory, you want to do everything non-gamma. Yeah, well, I know. Believe me, I know. Except not necessarily, like it depends what you really want. But yes, probably if we put this in and it works well, it should be default, right? Okay, so now, okay. So I'm just going to grab this And okay. Yeah, I think the matrices are different. We'll look it up. For now, we're just going to gamma the frickin' RGBs, and that might be wrong. Okay. RGB is it.color RGB if gamma all right. Okay. Okay. So here we do all this, we compute RGB. Okay. If gamma RGB.x is pow RGB.x 2.2, right? Y, Z, Y, Z. All right. Oh, right. Fuck, of course, yeah. For some reason, I hallucinated that we had a loop out here. Okay, this is getting a little complicated. Here's what we're going to do. I might be doing this wrong, like I said, but like I'm getting it out there, and then we'll fix it. So we're going to go for state. We're going to make this the outer loop, right? We're going to gamma the RGB, and then we're going to say in here, oh, we should complete this. Okay. I mean, it's not totally wrong. That looks muddier in RGB, but gamma is squishing the yellow. Wait, are we going the wrong way with the gamma? Guys, I think I'm going the wrong way with the gamma, right? No, that's right. I don't know. I don't know if it's right. So let's actually, instead of 2.2, right, just put that. Okay. So Oh yeah, that's right. There's the Oklab now. I remember that Raf did this. Um, let's click on that. I remember reading this and not agreeing with his conclusions about it, but yeah, see, this is kind of poopy. I forgot about the Oklab paper. We should look at that. I also still don't frickin' know the difference between sRGB and RGB. This is not, see, okay, the problem with this graph is that there's no maxima on the graph, right? Like, this is just from one point to another. You want to go through a point and back down so you can see the curve. So right away, I think this is a poopy visualization. I'm sorry. Because it doesn't, those were pretty colors though. sRGB is approximately gamma. Yeah, there's something though, isn't there something for like dim colors in sRGB? There's some extra tweak. It's like MOND, Modified Newtonian Dynamics. Yeah, I'm not going to worry about that for now then. Both IPT and Oklab does have better prediction of chroma and lightness. XYB. I think we're going to do just Oklab. Oh, this is the same page where we just were. Oklab conversion functions. JavaScript. Okay. Yeah, so this is doing the fucking low dim thing. We'll consider this. Gamma correction modified for sRGB thinger. Like, it would be good and educational just for me to read through the rationale behind this and understand it, right? Because I know that's a thing. I just don't know why or what's the point. Okay, RGB to Oklab. Why is it RGB to Oklab but Oklab to sRGB? The fuck? I don't trust this code all of a sudden, just for that reason. Original Oklab post. Yeah, I remember reading this when it was new. Okay, color in Oklab is represented with 3 coordinates. D65 white points, great. Perceived lightness, how red green, how blue yellow. That sounds reasonable. I feel like I did an Oklab thing. I don't know. HSV, literally, yeah, see what I mean? It's like HSV is like more Skittles. right? Whereas the Oklab is just like in there. Yeah, 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 yeah. Okay. XYZ to Oklab. I don't. Linear sRGB to Oklab. We should maybe just have gamma be on, right? All the time. Anyway, here we go. Using a higher precision sRGB matrix and exactly matching D65. Not going to matter for this application. Okay. Cool. Let's just type it in. All right. Boom. Linear sRGB to Oklab. C is a vector 3. We're not being strongly typed about these things. These look like they're more precision. I think the compiler is going to grump at us. We'll see. Okay. So CBRTF, the fuck is Kubertif? Kubertifa. The hell is a Kubertifa? Oops, I missed some F's. Ah, my completes. Cube root float. I don't have a function for cube root. That might be a problem. Oh, well, it's just POW, right? I mean, this is expensive, but when we want to hype it up, Kubertifa. All right, so we need to put some Oklab in there. Linear sRGB to Oklab. What we could do is just say RGB linear and RGB gamma. And we can just get rid of the gamma checkbox that we put so much effort into doing. All right. We do the target space, and then wait. Oh. Wow, this HSV really blew out. I guess again that's because of the interpolation. All right. We're going to complete this again. We'll do that. Okay, lab. Well, we're going to do this again. Actually, we'll copy it from here because it's going to be pretty simple. So we go lab, 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 and then RGB equals. There's probably going to be a way to make all this more compact, you know, but it is what it is. Okay, so RGB equals, okay, lab to linear sRGB, lab. All right, so let's do this. K, L, M, and S. We're cubing them like Cubert. Right. We got an extra brace here. L is not, all right. Oops. Typoed that shit. That would have been bad. Loss of information. Bruh. You got too goddamn many digits. Okay. Let's just. Right? Something like that. I don't know, dude. Oh, it's not actually these necessarily. It's up here, and we're getting type inferenced. Yeah, this is just too many digits, dude. Still too many fucking digits. Okay, now we're down here. Two, three, four, five, six, seven, eight. All right. See, if either you're doing the thing in float or you're not, right? If you're doing it in float and you have like trash digits, you're kind of just fooling yourself and everybody. So I decided to do this experiment a long time ago where, you know, I probably should have rounded this more carefully. Now we're here. All right. Fuck. Yeah. So it's one way that programs get like amateur and weird and lame is that they put all these digits in and they're like, I'm helping, right? And so I decided that we would not do things this way in this programming language. Human eye can't perceive the 10th decimal space. Yes. Wait, 363 would be 4, 451 would be 5, 376 would be 4. 1, 2, 3, 4. Oh. I truncated that one down there too much. Um, 4037. Wait, no, I'm looking in the wrong place. 883 024619. All right. 1, 2, 3, 4, 5, 6, 7, 8. 5, 0. 4, 9. 1, barely. 7. 5, 1, 7. Wow, all these are rounding up, which is kind of weird. What are the odds that almost every single one of these numbers is rounding up? I'm freaking out right now. Oh. Actually, then I cut another digit off and that one went down. Okay. Oh, this is rounded too short. Thanks. 40720468. Cool. Now, here, I also could see what I could do is just put the longer digits and then cast every one to float. But that's also kind of ugly, you know? All right, let's just go through here. 3963. We don't really care about this level of precision, but somebody might copy the frickin' code someday. 21580-375. Yeah, dude, they're all rounding up. It's so weird. 10556134 up. Boom. Oh, we rounded that one too much. 63854173 rounded up. 89484178 rounded up. 1.2914855. Oh, down. That one's down. Out of all 6 of these, one of them's down. 4076417 up. 3077116 up. 23096993 up. 1268438 down. 26097574 down. 34131934 up. So now we're at 4 out of 6 up, which is not that weird. 4196, that's the whole number. See, this is very sus. This is what I'm talking about. He's like, I'm going to put in 10 digits of number, but these are zeros. This is like less significant, right? It's like this fits in float 32, this does not. And the code doesn't. It's a problem. It's a problem. I'm not blaming this author because like this is just how C programs are, right? That's down 17076 147 down. Okay, so we got downs here. Oh, I had the actual numbers down here. La 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 tra la 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 tra la la. All right. So probably there's a mistake, right? So we have to gamma if we're going to see Oklab. Oh my God. Invalid arguments to POW. Minus 9 cragajillion. We're probably just passing uninitialized. Like I said, I probably made a mistake. Doesn't look like it though. Oh, wait. Color RGB. No? Looks like the US debt counter. Not yet, but we'll get there, dude. Don't worry about it. Don't worry about it. All right, so linear sRGB RGB to Oklab. Let me get a little bit of a drink. A drink. Like, listen, how nice is it that our standard library output us an easily readable log message that said, I don't like these fucking arguments, as opposed to us just getting a black rectangle and then debugging for an hour to figure out why it's a black rectangle, right? This is just so much better. It saved me so much time over doing this in C. Right there, that's productivity. By the way, we've got really good soap now that's about productivity. So that's going to be good. Okay. I'm just going to print this. We'll log it. Gamma, Oklab. Okay, so this is fine. We're not getting invalid arguments to POW. What? Oh, the invalid arguments was not in there. That's why I was confused. It's the exponent was 2.2, right? Which means it's not in the Oklab code. Well, now we're not getting our nice log message. So now I'm sad, but we know, I think we're just getting uninitialized memory. I wonder. I wonder if my POW is oh, you know what? Well, I don't know. I really don't know. Let's see. Gamma. Okay, L, M. So this doesn't like if it's negative. Oh, if it's right. Cube root, if it's negative, just says it's negative. All right, and we're going to go result. Result equals POW. F1 over 3 times sign, return result. Gamma, Oklab. Oh, we're not getting colors. But we're not getting errors anymore. Let's just do the old, we actually did go through this in round. Let's do the old back and forth. Retro is Oklab to linear sRGB. It target space. Print RGB, whatever, retro, whatever, distance, whatever. All right. Gamma. I mean, so the conversion back and forth looks fine. So probably, possibly, maybe, we're just doing the wrong thing down on the bottom. Down here, Oh, shit. That is a noob mistake. Oh, okay. Hey. Hey, everybody. Hey, everybody, I could program. I could program. All right. I mean, that is constant intensity kind of chill. And it's not going through weird hue space, right? So you might say it looks more muddy, or you might say it's taking a more direct path to the color. Although, fucking never mind, because RGB looks exactly the fucking same. That should not be true. Something's broken. See, I was giving you my explanation of why that's right, and then it's literally the fucking same. Which means probably I broke something. So, Oklab. I mean, dude, it looks like we're doing the right thing. The interpolation in Oklab. Oh, do I need to interpolate? Differently? The word interpolate does not exist on this page. Clue me in. What am I supposed to do? Yeah, okay, guys, never mind. It makes total sense that they're exactly the same. Because all we're doing is putting it through a 3x3 matrix. Sort of. I mean, we're taking a cube root, but if the cube root wasn't there, it's literally just a linear transform, which means a linear interpolation is going to it's going to commute with the linear transform, right? Which means it doesn't matter. Now, the cube root should matter. I'm not sure why it's not, but, you know. It might be time to take a break. We're 3 hours in. Oklab, Aras, I should learn how to pronounce his name. This looks nice. Yeah. See how this is pretty good looking colors right here. I like this. This is muddy and weird. He's not saying anything about the interpolation being different. The interpolation is the same, yeah. Well, I think those cube roots should make a difference. These should change the interpolation results visually. So I think we just have a stupid bug in the code. You have to interpolate in Oklab space. That is literally what we are implementing. That is literally what we are doing here. Okay, I'm a little bit paranoid about this. Let's just see what... Literally the same. What is happening? You can tell a difference. It's subtle. Really? All right. Well, let's try some different colors. So let's try colors like from Aras's page that we were just looking at. So he's got a blue and a yellow. It's like a straight up blue, right? Like way out in blue, and a straight up yellow. Okay. Here's RGB, gamma RGB. Oklab. Oh, it is different. It is different. And it is kind of getting us a little more greens in there. It's not drastically different. Okay, so now I'm convinced there isn't like a stupid bug in the code. It's just for people who are, picky about interpolation. All right, so let's give it some... Oh, you know what? Hold on before we do that. So I assume, Aramid Oklab might be the default. But yeah, by the time you do this, like the RGB isn't that bad, right? Like it's barely different, dude. Like if you're talking about particle colors, nobody cares. All right. Should remove the non-gamma. Yeah, we probably should remove the non-gamma version. I think I agree with that. The thing is, we're going to want to be more efficient about that because here... Oh, never mind. This part's fine. Yeah, never mind. We're only doing this once per keyframe. Let's just say gamma is true, right? And we're just going to get rid of this. And we're going to... this whole thing is gone. Oh, -0. Let's call this RGB. Okay. Yeah, I mean, Oklab versus RGB is not that different in the reds. Like, at all. Like, I don't see a difference here. Here I start to see a difference. Oklab gives a little more orange in the middle. Okay, but if we go to the blues, the moody blues, let's try this. That's more different. And then the yellow here. I mean, it's a little better. Honestly, the RGB one looks better here to me. Okay. Anyway, this is very successful. Like, again, finer points of color spaces and stuff we can figure out later. Oh, look at that. Look at that. That's better than a Photoshop. Oh, we didn't even do this. Look how good that is, guys. Yeah, the Oklab is slightly different. Congratulations. This is the kind of thing where programmers totally don't give a shit, right? It's not even clear that this is better. Okay, let's make the defaults be Aramete Oklab, all right? So down here equals cast S32 interpolation geometry dot Oklab or colors. Geometry dot Aramete, right? Okay. Boom. Well, I mean, I'm pretty good with it. 10 years of standard industry work. Well, it wasn't that much, but how many programmers do you know that would take a month to do this? Right? I mean, there's a lot of programmers who can't do this in a month, right? Like Facebook, Twitter style programmers. But like a lot, if you assign this task, some programmers will get it done in a day, some will get it done in a month, right? And that's just, like, we ain't even been working that hard today, right? And that's not to brag, it's just to show, like, look, you sit down, you have a system that's not pathologically broken and forcing you to deal with complications all the time. And you have a clear picture of what you're trying to do and what the priorities are and what the application is. And you have a personal coding style that does not involve overcomplicating things with OO or, continuation passing or Pratt parsers or whatever the hell is big this week, right? And you just get things done. Like, that's just it, right? Now, it helps a lot that I have, like, we're doing some domain specific stuff like color interpolation and whatever, and I've done that before. So, if you haven't done that before, it's easy to get confused and take longer. But yeah, like, you can, like, I just don't like what we've made programming into, right? Nobody will be surprised by me saying this. Let's get some juicy purples. Juicy perp. Juicy perp. Yeah, like, there's RGB, there's Oklab. Is it better? I don't, like, I think literally nobody cares. Well, it's weird. Okay, the RGB between blue and yellow was going purple in Aras's page, or RS, or I don't know. I'm sorry. I don't know how to pronounce his name. Right? So it was like, I'm just not seeing that. Oh, I see some purple here. I see some right there. But, like, it's not that bad. I think this is non-gamma, right? I think this is non-gamma RGB and gamma Oklab. Yeah, he's saying simple RGB lerp. So I think if this were just sRGB, it would be very close, right? The reason this is so ugly is it's non-gamma. Of course, we took away the gamma checkbox, so I can't try that out now. Is the color interpolation happening every frame? Yeah, no, it's literally every frame. Yeah, okay, this is true. So here in RGB, we're going yellow to blue, and in Oklab we get some green, but, like, is that correct? I don't know. I kind of don't feel like it is. I mean, I'm not saying our code is wrong. I'm saying maybe yeah, but like we said, okay, what the reason this is what it is so that people can make a choice about what they want, right? And there you go. Okay, we're going to take the W. I'm going to go to the store before it closes. I'm going to put on the list, though, ability to set default color, space, interpolation, geometry, etc. on the theme. So right now I just sort of hard-coded it on the state. But when you go instantiate a widget, you just want to be able to say on the theme, for your application, do you want it to start in RGB or whatever? And then we need to think about if we care about this. So tomorrow, like, I mean, we kind of did everything today, guys. You know, tomorrow, it's more about like bug fixes. Maybe the fourth channel value, that's going to be kind of big. Time view is going to be kind of big. So these are sort of the tomorrow things. I don't know that we're going to do as much tomorrow as today because tomorrow's a big dance day, but we'll get some streams in, and we'll probably do one more tonight. Actually, let me do this in the order of how much I care. So I think I care about these, and then this bug. This is pretty big. That's the order that I care. Let's celebrate with Diablo. I still have not even launched Diablo 4. I've had it since launch day. I'm just too motivated to do other things.